have. Our next speaker is Dr. Derek Gavra. Derek is a lecturer in biomedical and life sciences at Lancaster University. He's also a fellow for the Centre for Social Futures, and since 2023, Derek has served on the editorial board of Scientific Data, where he handles genome and language dataset submissions. So over to you, Derek.
Well, thanks very much, Tom, and thank you to the organisation for the invitation as well. So I'm just going to try and, yeah, okay, that's fine. So yeah, I'm on the editorial board of Scientific Data, which is published by Springer Nature. Occasionally you'll see people try to cite it as Nature Scientific Data along the model of Nature Communications or Nature Genetics and so on, but unfortunately that won't work actually. The official name is Scientific Data, so you don't get to put that magic word Nature on your CV quite by publishing in Scientific Data, but nevertheless I think there are several good reasons to consider putting your data there. The first one is that we accept a very, very wide range of data sets. I mean, really, I'm not sure whether when the journal began, they really planned on such a wide scope, and probably at the beginning it really was just scientific data, but now we're including all sorts of stuff that's not found traditionally within the science faculties of universities. So for instance, as you can see from the front page of the journal, currently we have the sort of the front page, cover page is a high resolution of data set of roads in the Roman Empire. So anything that has data we now define as scientific, and that can be stuff from the humanities, from the social sciences, and so on. Scientific data has quite a high journal impact factor at 6.9 and is still on the way up with a 5-year journal impact factor of 8.7. And this I think echoes something that I noted down that Vanessa had said this, that you get possibly more hits for research papers if they have an associated data paper with them. So it's well worth your while to publish in Scientific Data in order to get your citations up and get your H value up if you use metrics like that to judge your achievement. We have a reasonable time to acceptance from submission, so it's about 5 months or so. That includes absolutely everything. It could be faster, and we do want it to be faster. What we really need is more members on the editorial board and a wider range of disciplines on the editorial board. So if you are interested in becoming an editor, then please pass your email on to Tom. Perhaps if I can ask Tom to collect any inquiries like that, and then Tom can pass them to me, and I'll get in touch with the editor-in-chief and see about getting you an introduction to the editor-in-chief. One of the things that we emphasize is that we're primarily about data descriptors. In fact, the past two speakers have said very, very similar things. That we do also publish articles, as you can see on the top right of the screen there. That there are some articles, but there are not very many of those actually, and the preference has been really to phase out. The short commentaries are no longer published, and the preference I think seems to be to phase out articles and concentrate on data descriptors. One of the things that we're very keen on at the moment is to make sure that the data is deposited in repositories that are genuinely long-lasting and won't have paywalls placed on them at a future date, or won't simply disappear, and so on. So we encourage people now to put their data into public sector or governmental data repositories if they possibly can, in order to guarantee that the paper will refer to some data that's going to be available long after the project is finished, long after the funding is finished, and long after even perhaps the people involved have retired or are no longer working in the field. There's also a possibility of using your own institutional data repository. I mean, we have one here at Lancaster. I'm sure many other universities have those, but the problem with at least with the Lancaster Lancaster Institutional Data Repository is that it has a 10-year limit on it. So if somebody doesn't access your data for 10 years, then the university will delete it. So that's clearly not ideal, especially as the data sets age. They may be accessed less and less, and it'd be a great shame if they disappeared for that reason. So we are urging you to use something outside of your own institution, preferably with the government backing behind it. Now, I asked a co-pilot actually to survey all of the repositories and determine whether they were open access or not, or commercial. And some of the results are not strictly relevant. For instance, arXiv and bioarXiv that you see in rows 3 and 4 here are for preprints, which is not something that we would consider. But most of the others have been used at one time or another by people depositing in scientific data, or writing articles, data descriptors, and scientific data about their data that's deposited in these various repositories. The one that we're a little bit concerned about at the moment is GitHub, which is on the bottom line, because GitHub is owned by Microsoft, and there's been a little bit of chat apparently lately. I don't really follow the sort of tech blogosphere or substackosphere all that much, but apparently there's some worries about GitHub. So at editorial level, when a paper comes in that has data deposited in GitHub, where we gently encourage the authors maybe perhaps to choose something like Zenodo or Open Science Framework as an alternative to that. So that's one thing that we're currently working on at the moment, just making sure that the data really is available in the long term. So when you come to write an article, the first thing is that you must have your data set deposited. We don't like to send articles out to referees if the data is not available, and that's one of the things that will get your article sent back for modification, or not necessarily the article for modification, but we require you to make the data set visible before we then send the article off to, or the data descriptor more properly, off to referees for review. So that's the first thing. Make sure your data is in a public repository and that it's ready for the referees to look at. Now, the instructions for preparing the manuscript are very, very detailed, as you can see. And in fact, I'm basically just going to repeat what the previous two speakers have said, which is that you'll notice that there is no results section and no discussion section. So we really just want you to describe your data and validate your data, describe how the data has been validated, but don't go any further than that. Don't go into downstream analysis. Don't go into discussion of the potential future use of the data, or the potential impact of the data, or even the potential importance of the data. Just the data and nothing but the data, plus any validation that's necessary. So things to consider, first of all, another one is, do you actually have a data set? I mean, that might sound a strange comment, but we have been getting a few thin data sets lately. And we don't make this decision at editorial level whether a data set is too small or not, because of course the size of the data set varies by discipline. So we're relying on our expert reviewers to tell us if a data set isn't really big enough to merit inclusion. So if something is small, then we'll tell you to go away and wait a little while until you've actually collected more data and deposited it in your data set. And secondly, as I've already mentioned, you have to make sure that your data is public domain. Now, this is a difficult one at the moment, a little bit like the GitHub issue. It's a thing that we've sort of learned perhaps it needs to be changed, and that's again a table here generated with the help of Copilot. This is for genome data, which is one of the things that I primarily handle, and we do like genome data to be in GenBank on the top line here, partly because it's open access and it's not commercial. The same can be said of European Nucleotide Archive and DNA Data Bank of Japan, of course, as well. But GenBank is actually the one that most authors do submit their genome data to in the first instance. The one that we're concerned about is the bottom line, which is GISAID. Now, GISAID is a database that contains things like virus genomes and so on. It's a pathogen sequence repository, and GISAID is not fully open access, and we did actually have to bounce a paper recently where, in fact, one of the referees pointed this out. We didn't spot this at editorial level. I wasn't aware of this issue with GISAID, but one of the referees pointed out that this is not really public domain data, and therefore we can't actually publish this in scientific data, because our rules of engagement are that we only publish public domain data. So we're working on making sure that there aren't any wrinkles in subsequent submissions along this line. Okay, another thing to consider, and again, I'm echoing what the previous speakers have said, is do you have a data descriptor or a research paper? And there's no reason why you shouldn't write both. In fact, indeed, you probably should write both. You should write maybe one data descriptor, or perhaps if you have several data sets, you should write several data descriptors, and then you should write as many research papers as you feel the need of, but only submit the data descriptors to scientific data. Take your research papers elsewhere. So in that respect, we're a little bit unlike internet archaeology that wants to blend the two. We want to concentrate on the data descriptors, and we'll leave the research papers to all the other journals out there. So that's the end of my presentation. But what I'd like to do now is just to jump to the web page of the journal here, which you ought to be able to see. There again is the Roman road pillar on the front page. It's still there. Now, the content is here, as you can see. I hope that that's going to be visible on your screens, but you can see that there's a very wide variety of the recently accepted data descriptors. So there's the top one there is genome analysis, which is mostly my field, and then we have down here, there's another genome one there, and another genome one. So there's 3 genome papers, a metabolomics, so this is a physiological bioinformatics data set, and then we have a couple of neuro biology ones and so on. So quite a wide variety. And in fact, if you look at the subject list, you can see that you can in fact look for data descriptors in all sorts of different areas as well. And we are basically, as I said at the beginning, taking a very, very wide view as to what constitutes scientific data. There's also special collections. If I just click explore content here, one of the special collections that I was able to co-edit is one on, and you can see here the various special collection titles. So there's seismology and all sorts of things, water storage, it's environmental sciences, education data sets, and so on. The one that I was on is, let's see, it's in page 4 here. So page 4. Yeah, so I was able to co-edit this one here. So this is a text and speech corpora for natural language processing and corpus linguistics. You see that these are a set of papers which are focused on that particular area, and that most of them were accepted towards the end of last year. So what we do with the special collections is that we identify a subject area, put out the publicity, inviting submissions. The submissions come in, but they're reviewed in the normal way, and then they're published in the normal way, but then they are included, linked under the special collection, so that people that are interested in specific disciplines or areas can find them faster, and so on. I think what I'll do now is just finally I'll go. I mean, go to a paper and show you what one looks like. I mean, I realize that this is perhaps a little bit technical for those that you don't work on genomes, but if anybody is out there that wants to submit a genome paper, I'll show the kind of things that we're looking for. So here we have, this is crucial here in the data availability, we have our sequencing reads, it says, and it says what the technology was to generate them, and then crucially it says where they are available. And we link to the data using links like this. So for instance, that there will then highlight where the read archive is, and then we can actually see right the way through. So I'm going right the way through there to the original data, which you can download and look at as well. So that's the way that works. I noticed that these particular authors have got their code in GitHub, which is not great, but that one seems to have got through the net. We're trying to, as I mentioned earlier, to shut down on that slightly. And also another thing which perhaps is still a little clunky is that if you want to see the whole paper, you have to download the PDF. So you can't actually see the entirety of the paper on screen. You have to download the PDF, and as you can see, it takes a minute to load, but there we go. I'll just see if I can make that a little bit bigger. So it's got to be a data descriptor, which means that it must have, and unfortunately it seems to have gone over to the right hand side here, so I hope it's visible to everybody, but it has to have a relatively small introduction section which just describes a little bit about the material that you're working with. And then it's very important that you're very clear about what your sample preparation was and so on, about how you actually generated the data in the laboratory. You've got to tabulate various metrics of quality and so on. And then you have to do the data validation. So this here is telling us various technical things, which won't mean anything to you if you're not a genome sequencer. It tells us how good this particular genome is. Then we have further validation and so on, with more tables about what we think is there in the genome, what we think is missing, and so on. How well is it run? And there's a little overview at the end. Then a little bit on the data records, some of a bit more of the methods on the technology, and that's it. You notice there's absolutely no results in there, absolutely no discussion. It's strictly a data paper. And if you look at some of the other ones, it's exactly the same. I'll just quickly, if I've got time, do the same thing for one of a paper from another field. So I'll just randomly click on this stuff about drones here, and I wonder where are the papers on drones? Collection content, is that one? That one doesn't appear to have any accepted papers yet. Let's see if I go to number 3 here, and then or number 4. Let's see an older one, bioacoustic data. Let's try that. Collection content. Oh yeah, okay, here's one here. So there's actually one so far there. So this is about humpback whales apparently, and as you can see, that one does seem to have the whole article visible on the. So obviously some progress has been made on actually transferring all the articles so that they are visible completely on screen. Unfortunately, I don't seem to be able to see the figures terribly well. Never mind. But yeah, so it's the same principle, regardless of what your data is. You have to be very clear about how you generated it and what its validation is and so on. As you can see, all of this technical stuff about audio recording here, and more technical validation data and some figures if we could see them without downloading them separately, and then availability statements, and we're done. So it doesn't really matter what your subject is, it's all processed in the same way. So that's what scientific data is about, and I hope that I will see some submissions coming in as a result of this meeting. That would be really wonderful. So thank you very much. I'll stop sharing my screen now, and it's back to you, Tom.